Hello, my friends, and welcome back to our tier part of courses. And today we will continue our journey into Siemens PLC programming and automation. And today lessons is about the PLC memory and wiring the PLC. So let's start with the PLC memory type. Let's open our notepad and print. So firstly, so commonly we have the 5 type of memory area in our S7-1200. It's first of them, it's the PII, let's write capital, and description of this memory is the CPU copies the state of the physical inputs to memory map in the beginning of the scan circle. So if we have PLC, this is our PLC, and we have the let's do it like this, and this our input, and this our output. And in first circle our and also we have PII memory, this one. And firstly, in the first circle, in the beginning of the scan circle, our PLC copied the physical state of these inputs to our PII memory. It's a process image input. Let's write it like this. Process input image. The next memory area is our process image output, and let's do it like this. PIO, and write it here. Process image output. Sorry, my friends, here we write the process input image, process image input. And PLC at the beginning of the circle copied the output, physical output state to this memory. The third is our bit memory. We write it like M. And what is this? You know that the user program reads and writes the data stored in M memory, and code block can access the M memory. And you can configure the address within M memory to retain the value of the data after the power circle. After the power is off, or when you start the program, you can use the M memory for store, for example, for the functional blocks. And next one is our temporary memory. We write it like L. Also, you can read about it as the local stack. And my friends, why we used it? whenever a code block is called, for example, the function, the block can which cannot store the data, that will not use the retained data. And when this block is called, the CPU allocate the temporary or the local memory to be used during the execution of block. And when the execution of the code block is finished, the CPU relocates the local memory for the execution of the other code blocks. And the last one is the data block, in which we will use this data block in another lesson. In this lesson also, but more we used in the semantic manager lessons. And we use the DB memory, the data block memory, for storing various type of data, including intermediate status of the operation or other control information parameter for the functional blocks and for the data structure and for the arrays when we work with the trends, and also when we share information and send the data to HMI or our SCADA programs. And also, my friends, let's talk a little bit about the wiring. Let's open our schema and do it like this. Okay, let's select this one and crop it. Sorry. Let's select it again like this. And paste it here. And now, if you want to wiring this, firstly we wire our L line and our neutral. It's our phase, and here we put our neutral. And then if you want to supply the power from your PLC to the sensors, we must connect our output number 5 with the output number 6, and then you supply the power to your devices. Let's do it like this and this, and then sorry, and we do it like this. And here we have some contact. Sorry for my painting, but like this and like this. And the next one is our analog signals. And for example, if we have power supply here, this one, and we have the plus here, our plus like this, and minus here, we will do our connection like this, and we take the minus and connect it to our first input, like this. And plus we connect to it to our sensor firstly. This is our sensor, like this. And then from if we talk about potentiometer and potentiometer, I think it's right pronunciation. And we have 3 inputs here. Let's do it like so. Let's do it like this. Is our first connected our plus signal, second and third. Then we do it like this. We connected the plus to our third input here, and then we connected second output of our potentiometer to the our second input, like this. And lastly we connection our first input, first output of our potentiometer to our sorry, let me check this, to minus, like this. And the same for our digital output, like the input, we use the same connection. And here we do like this. Firstly, it's our line, and we make our connection from the line. We come here and connection to our 2L and 1L, like this. And after that, if we want to connect it, for example, we want to connect some lamp here, like this. Let's make it. Okay, now it's similar like a lamp, and then we connect it to, let's do it like this, connected to our neutral. So my friends, that's all for today. I wish you good health and good like, subscribe to our channel, and give a like to our video if you enjoyed and find it useful for you. Thank you very much, and see you in the next lesson.